Chairman President Huang, President Spinrad, President Guerrero, and distinguished guests from abroad, and ladies and gentlemen. It's an honor for me to be able to give you a glimpse of Taiwan's national energy program. Like President Huang just mentioned, starting about 2004, I was called into different responsibilities in Taiwan's different research institute. When I was supervising the overall engineering and applied sciences funding program in National Science Council, I thought 3 years would be enough. Then I was called upon to serve as the executive vice president for E3, which was was founded 40 years ago, and it is a 8,000 people research institute. And then I was called upon to serve as the president for III Institute for Information Technology. So after 8 years, I say, finally, I can go back to serve and be happy as a professor at National Taiwan University. Around a year ago, two ministers from the National Science Council and from the Ministry of Economic Affairs, indicating that the phase 2 of the National Energy Program want to be in a completely different structures, meaning that the first time a cabinet member will be asked to serve as the PI for this project. And this is a $5 billion project for the next 5 years, and across different ministries, different universities, different research institutes, as President Yang and President Lo and President Huang just mentioned. So when Professor Chiu asked me to give you a glimpse of this particular problem, I say, this may be a good chance to be able to invite all of you to help us to further establish the technology on the ocean resources and how can we further advance the renewable energy side of the national program. The first few pages just give you a glimpse of when we begin the replanning of this particular program, what we have in mind. This is actually everyone in this room knows about this one. Say the 10 questions about the next 50 years. As you can see here, the first 4 are very closely related to carbon dioxide emissions in the technology. And further on, the observed change in the climate systems, as you see here. And in this particular structure, further on, with the severe weather situations globally, it's actually a very severe situation. Further on, the temperature rise in the ocean present a very large potential disaster parameters in Taiwan. In fact, in the last 10 years, Taiwan sees the very large flood due to the rainfall, and many of the engineering practice actually breaks down. Many of the civil engineering professors told me that in the last 10 years, they saw several of the 200-year cycle, the so-called rainfall, appear in Taiwan within the 10 years and appear many times. So that which caused a very strong problem in Taiwan. Some of the reason comes from the severe temperature rise very close to Taiwan, as this chart actually indicate. Certainly, the carbon emission continue to rise. This last year, in fact, probably this year, will present in human history the highest carbon dioxide concentration in the atmosphere environment. So therefore, it is also well known through the global research indicating a strong and high concentration of carbon emission were closely related to the temperature rise, which certainly appear in the last several years in the severe weather conditions globally. But to make the situation further and actually making us need to be further aware of the situation is the energy usage as we currently, our society sits on. We also usually consider a country or a location or a region which utilizes more energy, which is more advanced. This chart is a composite chart from the NASA satellite picture in the midnight. As you can see, the brightest area then usually means those areas are, in our typical view, their technology, their so-called civilizations are more advanced. So in this chart, and many of the global studies indicating the energy usage will continue to rise, and the population globally will certainly continue to rise. So therefore, from this chart, then we see the energy structure will appear. If we do not do something, then after all the lights are go out, then human society may go back to the cave situations, as it shows here. So therefore, from that, that's a global situation. How does Taiwan look like? Several of the opening speakers told us Taiwan is small. Before I really rethink of the Taiwan's national energy situations, I was looking at the roughly what Taiwan's industry should look like. And it's actually very interesting. When I begin to investigate and talk to many of the researchers globally, we found out we are in a very interesting and strange situation, as you can see. Like you can see here, the population of Taiwan is 23 million. The overall land area is only 36,000 kilometers square. It is the densest populated area in the world. In fact, 70% of Taiwan Island is actually mountainous area. Further on, to make it even more interesting, like President Yang mentioned in his opening speech, indicating there are 15,000 kilometers of the coastline near Taiwan. And their sea area, there's 120,000 kilometers square. To make it even more interesting, 65% of the biospecies of the whole Asia area can actually be found in Taiwan. And 10% of the global marine species can actually be located near the Taiwan coastline. If we look at the right-hand side of the chart, we say Taiwan should serve its industry globally as a tourist industry. It's like Hawaii, because it has such a good marine biodiversity, the biodiversity in Taiwan. And then we have all major climates in Taiwan, all the way from tropic, subtropical, to actually the warm climate situations. And there are well over 1,000 mountains in Taiwan. They are taller than 3,000 meters. So therefore, it is an interesting, but typical perception on Taiwan is definitely not Hawaii. I believe if we are in Hawaii, many of you should be wearing shorts, not in your suits at this moment. What's the typical perception of Taiwan? It's on the right-hand side, bottom corner. Taiwan used to be the manufacturing powerhouse of the world. In fact, when Taiwan has an earthquake, many of the global high-tech industry has a strong hit because most of the notebook, most of your iPhone, many of the ICT technology, cell phones, 85% of the GPS personnel device are made in Taiwan or made by Taiwanese manufacturers. So therefore, Taiwan is an interesting situation. 30% of the GDP in Taiwan are used in energy. But simultaneously, we have such a strong biodiversity, and therefore the environmental impact as we move forward, it becomes a very interesting and very important issue as we plan forward. Further on, looking at the global energy trend, it is very clear as the current situation, no matter how much effort each nation put into its efforts, the energy usage and consumption rate continue to rise. Certainly also the chart also indicating that we need to have a better renewable energy usage, as it's indicated there. The continued rise of the energy rate typically estimating at around 1.8 to 2%. However, the renewable energy needs to be about 2% to 6% in order to satisfy the global need. In this chart, to make it even more interesting, looking at the statistics in Taiwan, like I mentioned, about 98% of the Taiwan energy is actually imported. And if we look at the situation, it makes it very interesting. With the biodiversity I mentioned to you, and then with the manufacturing capacity and manufacturing intensity in Taiwan, we simultaneously present a very interesting problem. Taiwan is also an isolated grid. We are not connected to any other areas through electrical grid worldwide. So therefore, the government cannot just jump out and say, starting from today, we're going to stop one energy and move forward to the other, and then try to buy energy abroad, meaning buy electrical grid from abroad. because 98%, or in certain statistics, indicating 99.4% of the energy in Taiwan are imported. Simultaneously, Taiwan utilizes about 1% of the global energy consumption. The energy consumption in the last few years, this one, even though I use 2006 statistics, in the last few years, this statistic does not change too much. The industry utilizes 51% of the overall energy, and the daily life and the business utilize 18%, transportation use 15%. The electricity utilized somewhere around the same proportion as indicated in the next line. To make the situation even more severe and even more alarming for Taiwan's planning community, it's the carbon emission versus the GDP, which is typically we call energy densities in each nation's planning. If we take 1990 as the baseline, all the way in the last 20 years, Taiwan's each percent of the GDP increase are closely related to 1% of the carbon emission. This trend only began to deviate in the last 5 years. But that deviation is not strong enough when compared to other OECD countries, which is the reason why many of the leadership in Taiwan indicating that we need to strongly and quickly change the manufacturing paradigm in Taiwan and also the industrial horizon in Taiwan. As you can see from the environmental issues, from the energy consumption issue, from the carbon emission issues, Taiwan faced a fundamental change in terms of its energy structures. And how can we utilize the interesting and unique geographic and geology structures in Taiwan? So when I was called upon by different ministers, say, now you need to, again, help the government, working with the cabinet, try to rearrange the national energy program. So we call upon a very large community with different experts from completely different fields to work with us. So the 3 themes we put in the structure is the security, the national energy security, the efficiency, increasing the energy efficiency in Taiwan's industry, and the cleanness, meaning reduce carbon emissions in Taiwan structures. And inside are different focus centers and linkage divisions, which we mentioned. So this is the structure of the National Energy Phase Program. This PDF file of this particular presentation can actually be distributed, so you really don't need to take a picture. You can get the PowerPoint files on your own from the organizers. Like I mentioned, the PI of the overall project is the Deputy Minister of the Ministry of Economical Affairs. This is the first time in 20 years in Taiwan's national programs that a cabinet member who has political responsibilities and has to face the Congress to do this kind of job. And I was called upon to serve as the CEO. The deputies is still not appointed because the different ministries want to have one of the particular bureau chief to serve, and the Congress haven't passed the reorganization of that particular government. Inside, we have the linkage center, which serves on the communication, meaning communication with the society, the fishermen, when we try to do offshore wind farms. The international collaborations, meaning that the program understands our technology, especially in the energy side, is definitely not world-leading. So therefore, strongly collaborating with global teams is certainly an important issue. And strategical planning indicating all the way from now to 2050, what kinds of energy distribution within Taiwan should be planned for, meaning that what will be the baseline, how much energy comes from coal, how much comes from hydro, how much comes from wind farms, things like that. The left side is the one which we think will make an immediate impact in Taiwan's technology, meaning using ICT technology to serve in terms of the virtual power plant and the energy savings, which including solars, some of the bioenergies, and then also the conservation of energies, and then also smart grid programs. In this year, and in this phase of the program, we asked the Thai Power Company to strongly correlate it as the core of the overall program, asking many of the program be able to latch closely with the Thai Power to make sure the linkage and the implementation will be possible. Those are the ones we call the virtual power plant and the energy management architecture. For this particular talk, I'm talking about the right-hand side, essentially the emerging energy and carbon reduction architecture. In Taiwan's technology, those in the geographic situations, those are important. But within 5 years, it's not easy in terms of the Taiwan energy structure to immediately make a very strong impact. However, we also did a study say, can we wait and until the technology is mature, then we just import the technology globally. But we did a detailed study indicating even with that, the local information are important. If the technology mature without a local information, we need another 10 years to collect all the information. So we bravely, and with the permission of many of the advisory committee, move forward with the areas on the offshore wind farm technology and the corrosion current technologies. And then also the geothermal energy and gas hydrate, and then carbon reduction, and then also clean coal focus center. Those three, most part of the right-hand side of the architecture are closely related to today's UA conference, the Ocean 14. So I'm going to give you sort of like a closer view of each one of the focus centers. The offshore wind technology and then also the marine technology side, the view is actually interesting. If you look at the Taiwan structures, 8 out of the 10 best wind areas, wind farm area globally is actually in Taiwan, near Taiwan coastlines, because of the Taiwan Strait. As the northeast wind side, wind comes in from in the winter time, through the Taiwan Channel, the accelerated effect actually making that place a very good wind farm areas. So therefore, there is actually an interesting situation that Taiwan actually, because of the way we locate right on one side of the Taiwan Strait, then we have a very good location to be able to install the wind farms. So therefore, the program is say to accelerate the Taiwan offshore wind farm development and try to localize some of the offshore wind power technology and certainly to promote the ocean power technology applications. As it stands now, the Department of Industrial Bureau at this moment asking for by 2020, 600 of the new offshore wind farm has to be built. Because of that, each one of them is 3 to 5 megawatts of power. So therefore indicate a very strong implementation requirement for the government side and the industry side, as well as the research institute side, to be able to create the technology, the infrastructure, the alliance, to be able to establish that particular program. So this is a detail of the chart, which I'm not going to go through in details. It's going to talk about the offshore wind farm development, the offshore turbine localization and R&D, and marine engineering, and the also underwater structures. So therefore, currently 4 companies, 2 small and medium companies, 2 very large national enterprises signed an agreement under the monitoring of the Bureau of Energy. They signed the agreement and MOU and also the contract with within the government and within each one of the alliance members to try to establish immediately the 2 pilot wind farm projects and offshore wind farm project. An additional 28 will be built in the next 2 years. Related to the biomarine studies, the white dolphin impact, the undersea geology structures, and many of the studies are simultaneously in place. The research program are being reviewed and will be funded the first year next month. In addition, the marine energy technology, these 6 focus centers, actually is a reduction from the phase 1 of the program. Phase 1 of the program has total 75 main part of the project simultaneously ongoing. After detailed studies, we indicated offshore wind is important, and several of the other technologies are important. So we reduced the overall project to 21. Like the discussions on some of the studies on OTC, ocean thermal research, and all those are terminated in the current phase of the program because of the Taiwan energy densities and the local geographic and geology structures. However, the corrosion current project remains. The reason for that is, as you can see here, the corrosion current density in Taiwan, near Taiwan coastline, is actually high. And if you look at the global structures, the corrosion current this corrosion current is one of the one which nearest to the land. So therefore, the power line transmission, if it's a possibility to generate some power from there, then there will be a possibility to be able to pull the energy. Certainly, many obstacles and suspicions on see if this technology is possible. Some of the private companies already invested the last 5 years try to develop this technology. Our view is like this. This technology, by the end of this phase, my responsibility to all the cabinet members then will be to tell them, can we invest a significant amount of money in each line of the technology? If not, why? If yes, how do we proceed? So therefore, the pilot project and how do we proceed along this line then become very important. The geothermal side will start with the land base, but this project and this part is similar to any other nations, such as we have a detailed collaboration with Japan's programs, indicating most of the very good geothermal sites are typically within the national park. So how do we work together with the national park to be able to do a geothermal project correctly? Then will be important. Taiwan runs through the last 2 phases of the program, and this will be the 3rd phase of the geothermal project. And because of the geographic structure and the geology location of Taiwan, the abundance of the geothermal energy density in the Taiwan island is actually quite clear. The problem is then how can we do the deep drilling technologies and how can we pull the energy out and simultaneously without impact the environment too much. So then there will be a major issue. There's a strong discussions within the community on how do we pull together the overall technology in that site. The gas hydrate side is also important. Recently, there's studies in the southwest side on the coastline in the Taiwan's gas hydrate, and indicating starting from the middle side of the Taiwan Strait, the closer to the Taiwan side, has abundance of the gas hydrate. And the detection, high-resolution survey of gas hydrate in that part indicating a very large percentage and potential concentration as well as the reservoir of the gas hydrate. The technology as well as the biomarine impact are currently being studied. The German research vessel Solar helped with some of the early explorations, and the Focus Center Director General just signed a contract with Tiger 5 project, tried in the German research vessel, try to further explore these particular areas. So therefore, the geothermal and the gas hydrate side is also representing a research aspect of Taiwan National Energy Programs. The last phase, the last part of the focus center is actually the carbon emission storage, captures, and reutilizations. So those parts, in addition to all the typical structures, in the northeast side of Taiwan, there's a cement production areas. So currently, the research utilities and research organizations and the teams are trying to use that site to capture the carbon dioxide emission and also store inside there. So various capacities and try out on the technologies being utilized and developed in that area. So those are the roadmap. So my time's up. Why does Taiwan plan the National Energy Program this way? Certainly, we realize that this is a chart that we borrow from Japan's 2050s plannings, indicating a typical motor vehicles replacement take about 12 to 20 years. If we talk about the nuclear plant, 30 to 60 years replacement are typical needed. The coal power, 45 plus years. Taiwan built 5 of the new fire power plant in the last 5 years and currently in manufacturing or in constructions. But anyway, with all those, with the time cycles needed, the energy program of any nation take a long time, but simultaneously understanding the development and the importance of the renewable energy representing a very strong side of the Taiwan's National Energy Program. So as it stands now, this is the last chart of the program. We try to make, at least with 1% of the efforts of the global structure, we try to make Earth from this side to that side. That concludes my talk. Thank you very much.